Let's just kick it off then. Looks like we got a nice group of folks here to join us from what I can tell, different parts of the country, which is going to be great for our topic today, which is drought management. And before we get started into drought management, I just want to remind everyone that all the previous episodes of Tech Talk Tuesday are available on YouTube. And Dan has actually changed the naming structure. So now on YouTube, you can go in and you can look at all of season 1 or all of season 2, and then the episode number. So if you want to watch them in order, you can watch them in order. If you want to search for keywords to watch them based on keyword relevancy, you can do that. But the library is getting quite deep, and we're excited for the type of content that we've got there for you.
I'm glad I logged on today. I learned something. I didn't know that Dan had made those efficiency enhancements.
Mm-hmm. Yeah, I had to ask him 26 times, but he finally did it.
I'm doing it in a different place.
And what is the YouTube handle?
Baseline Web Training, all one word. We make it easy for you to find, all one word. And before we get started, we'll do a quick introductions. I'm Andy Humphrey, Irrigation Technology Consultant for Baseline. And we've got Chris Wright, our VP of Sales.
Everybody.
Dan Conger, our Training Manager, who will lead us off in this discussion today on drought management.
Beautiful. Hey, one thing on YouTube channel is that search function works really well, right? I was searching for a customer and I did learn flow, and every time learn flow came up, those tags pop right up. So it brought up 6 or 8 different videos. So that's a great feature to use.
Very cool.
Drought management. I'm in the West, so this has been near and dear to my heart. It's either when are we not in an issue managing drought, but it's definitely something that's significant. So Chris has this great graphic that you brought up, and I think it really goes to, it's a great visual smack upside the head as far as why we have issues, right? So if you kind of look at the West, there's a lot of red and a lot of areas that are impacted by drought and lack of water, and even places in the East, they don't skate away. What was really interesting is I'm in that lower corner, that yellow corner in San Diego and the Southern California, and we're yellow. And I thought that seemed a little odd that I'm not as dark red as Utah, Nevada, and other parts. Well, then I realized we get our water from Colorado River. So 75% of our water is imported. So we get our water from drought-stricken areas or from drought-stricken portions of our same state. So it's just a double smack for us.
Yeah, and this graphic, it comes off the U.S. Drought Monitor. So if you just go on Google and search for Drought Monitor, it'll pull this up. They update it weekly.
Oh, wow. Okay, I didn't realize that. Yeah. Yep. What does the SL and the S stand for? Do you recall? Because
severe long-term, I believe.
That makes sense.
Something like that.
Yeah, that sounds right.
Yeah.
So it is kind of interesting, right? Those watersheds and how those impact it. And when I did my water conservation consulting gig, there's some agencies that govern an entire watershed, right? So it's cross states, cross water agencies. So it's significant. So we wanted to kind of bring up some of the things how Baseline is involved in this and how we can help manage some of that. And we actually got to get my slides to advance first. There we go. Talk about water rates, just the pure expense. So there's two aspects of it. I say there's water rate to actual expense, and then there's water availability, right? So when drought gets severe enough, it doesn't matter how much you're paying. You may just not have it legally available to you. It might be, nope, you can't water outside, or you can only water this amount, or you only have a restricted amount. Mm-hmm. But speaking to water costs, Chris, this is from your water bills?
Yeah, this is actually my water bill. And I think this kind of illustrates some of the problem as well, right?
Yeah.
Because I know this is drastically different from you, but if you look at it, I'm paying in block 1 $1.37 for 748 gallons of water, right? So I can't even, buy coffee for that price.
Sure.
Right. So it's crazy how cheap it is. And that contributes to, a lot of misuse of the water. And so in an extreme or exceptional drought conditions, there's got to be more penalty or reason to conserve. And so then they do the block rates. And so if you use more than you should be using for an allotment, then they'll charge you a premium for that. But even in my area, that's not much of a penalty. Whereas for you in San Diego,
wow,
what do your rates look like?
So my block one or tier one rate is $5.38 for the 748 gallons. So that's tier one, all the way up to tier four or block four, $11.84 for 748 gallons of water. And I go into block four or tier four at 18 units of water. You don't go into it until you hit 61 units of water. So you can get into this. Well, I kind of did a little math problem, and I said, well, what's 24 units of water? For you, it was about $50. For me, it was nearly $300.
Yeah. Yep. It's crazy. So depending on what part of the country you're managing water in, this has a significant impact on the bottom line for the property owner, right? Yeah. So they're going to want to manage that correctly so that they are not, being charged more than absolutely necessary for that service.
Right. And I think the other thing that happens is when these tier rates when they really clamp down on them, what happens is the water costs, what they budgeted, they're completely out of hand, right? Mm-hmm. So last year we spent this much on water, and what are you telling me? We're spending, another 50% more on water. And they're going to go look to the person that's managing the water and say, you got to do better. We need to change something.
Right. Yep. So as I look at drought management,
you either change the management or you change the manager, and we don't want the managers necessarily to change. So let's change the management.
Is that kind of like, if you can't change the person, change the person? Andy?
Right.
Yeah.
Kind of.
All right. Very good. Yeah. So as I look at drought management, there's the cost, and then there's also in the tiers, but there's also the mandates, right? Yeah. So, a property owner may be approached by the water district and says, we're mandating that you have to use 20% less water this year.
Right. Just period. Yeah.
Regardless of the cost of it, just you have to use 20% less. So there's different capabilities with the baseline technology where we can manage that correctly and make sure that either we stay within a tier rate or we adhere or comply with the mandate that's imposed upon us.
Right. So I think you're talking about budgeting and rationing right straight off. Right?
Exactly what I'm talking about.
Yeah. What's awesome is, so while you might have additional costs coming from water that you can't be avoided, you can manage those with the controller you already have, right? These are built into the base station 3200, setting up a budget for a water source or rationing off of a water source.
Yeah. Yep. And the thing to emphasize is this is available out of the box, right? This isn't another add-on capability to the controller. This has been part of the 3200 platform for a number of years. And I really don't know how often it really gets used. But in times like these, it becomes more and more of a priority. And I think it's important for people to know it's available to them.
At times I've tried to walk people in baby steps towards setting a budget just to see how much they use, right? Just see, if you think you might use, 100,000 gallons in a month, put that number in and then see how you compare against that, right? That's a baby step. But using the rationing feature is more than a baby step, right? That's actually holding you accountable or measuring it on a daily basis over a 30-day month and allocating that water on a daily basis.
Correct. Yep. So the way that you can use this in the platform is you can set a budget, and then you can set that water source to shut down once it's used that amount of water, or you can leave the box unchecked to shut down. But when you use that volume, then it's going to send you a message and let you know. And you may find out that you use that water, in the first 2 weeks of the month.
Whoops.
Or you managed it better and you're getting closer to the end. The point is that it gives you an indicator of where you're at, so you can make decisions to manage the water more appropriately.
Right. Now, we can do this for each water source, so up to 8 different water sources on a single controller. So I could have 8 separate water budgets for each meter. And some meters, that tiered rate might hit at a different level. At a 2-inch meter versus a 4-inch meter, it might hit at a different level, and we could help manage those costs by doing this one. But the other one is if you have a secondary water source that's a lake, a pond, or a rain catchment or something else. Well, we're going to prioritize and use that first because that's free water. We're not paying for that. But when it runs out, then we can switch to another water source. That's out of that prioritization.
Mm-hmm. Correct. Yep. And for those clients that are on a well, for instance, just because they're on a well doesn't mean that well water is an infinite supply. And in exceptional drought conditions, a lot of the groundwater goes away, and their well just may not produce as much as it was previously because there isn't the groundwater there. So you can budget it and ration it or monitor it so when you are, at risk of not having a supply of water.
Right. Nice.
Okay, so let's talk about how that water source rationing works, for example. You input a budget. In this case, it's 2.6 million gallons, which will make sense in a moment. The water rationing box is checked. So what that means is if I put in that 2.6 million gallons at the beginning of the month, then the controller will allocate that water over a 30-day period or a 31-day period for that month. If I'm not irrigating every day, or I am not irrigating because of some kind of sensor input, say I skip a water cycle because a moisture sensor says I don't need water, then it will take the water that was allocated for that operation, bank it, and allocate it over the remaining days of that month, right? So if I put that 2.6 million gallons in on the 15th of the month, then if I have long enough run times in my control system, it will try to use all of that 2,600 gallon or 2.6 million gallons in that 15-day period.
So adjusting it then for the midway through the month sounds really important.
The duration that's left in the month.
Yeah. So that 2.6 million gallons, that's a big number. Well, it's a big number, but it's also a number in gallons. So we were talking earlier in units, or 748 gallons to a HCF. But you did some math on this one, and I just threw the slide in just before we end. But so walk us through the math on this one.
So this is a site that I worked on, a RFP for a property or a parks department in Arizona, illustrating how this capability or programming works. And this park is 5.46 acres. In that area, the historical ET for turf grass is 10.54 inches of water.
That's for a month.
So then we can use, some of our CLIA skills from the IA, do some math based on plant water requirement and distribution uniformity, and we can determine how many gallons would be required in order to meet the plant water requirement for that turf grass. So if we know there's 27,150 gallons of water in an acre inch, June water requirement at 100% DU would be 1.56 million gallons. Now, that obviously is not perfect distribution uniformity on that park. But if we were to assume a 60% DU and adjust that water requirement, it would be 2.6 million gallons.
So 2.6 million is the amount of water that it would need to
meet plant water requirement for that turf grass in the month of June in that area.
Right. Okay. So that's how you got that number. Excellent.
That's how I got that number. Yep.
That's science. It's real science.
It is real science. So if you were to take that example and plug that into my water rates, which are, ridiculously low, it would come out where it would cost over $12,000 for the month of June to irrigate that park. Okay, so, and it got obviously into tier 4 or block 4 because I was using more than 61 units. So there was a lot of usage in that penalty category or that highest tier. So you can imagine what that would be like for a site of similar size in San Diego County.
Ouch.
Right. Yeah. And then, we're 5 times or more that cost for the water to keep that plant water requirement on target.
Now, I think you're bringing up an interesting side note is that as water managers, we're often removed from the cost of the water, right? Because if you would have said $12,000 to water that, are you kidding me? Like that's in 1 month. But if the more in touch we can get with that, or more in touch we can get with the actual gallons, I think the better we'll all be.
Yeah. So if I was, a landscape maintenance contractor or working for a parks department for a city, I'd want to be aware of those numbers so I can go to client and be proactive in how the water is being managed in an effort to, manage the fiscal budget or financial budget as well as the water budget.
Right. Good. Awesome. Well, we've got some other technologies that we wanted to bring up. The one I wanted to show you was start, stop, pause conditions, which we've talked about before. And time and date is a condition in which to start a program, but we can set up any other condition based off of any sensor input. So for application for drought, which actually kind of applies to this your last image with those crop circles on there, I set up a pause condition based off of a pressure transducer. And I said, when the pressure drops below 40 PSI, I want it to pause for an hour and then check again. Why? The reason I did that, well, my rotors do best at 50 PSI. When the pressure drops to 40, that DU just goes to crap, right? And this is like, well, why waste that? Why get the donuts? Let's just wait till the pressure comes back up at the right time of day. I'm not going to waste that water and get more bang for my buck out of that water, so to speak.
That's right. And I think we've discussed on a previous episode of Tech Talk Tuesday that a 10% difference in pressure can have a 40% impact on the amount of water that's used to irrigate an area, right? Nice. So managing that, monitoring it closely can also contribute significantly to your water management program.
Now, the next one, program priority, I think goes back to budgets that you talked about. So if I don't have enough water to water everything on my site in a day, there's going to be somebody's going to get shortchanged perhaps because we've rolled it back.
And a lot of that depends on how a site is hydrozoned as well, right? So in that previous example with the park, if they wanted to keep the pitches or the playing surfaces greener or healthier than the surrounding area, if it was hydraulically designed so it was possible to irrigate the playing surface from the surrounding area, then they could prioritize the playing surface and have that budget be allocated to the playing surfaces and then let the surrounding area, go into drought stress.
Right. And you could do that by having one program, those more important ones in a higher priority program, and make sure that those get a water before the other lower priority programs water.
Absolutely. Yep.
And normally I kind of advise, I bring it up on program priority is to use them with a purpose. Don't use them just for fun. This is a very dedicated purpose. And I think this fits exactly what program priority suits well for.
Definitely. Yep.
Cool.
Engineered solutions.
Nice.
Right.
Then, of course, soil moisture sensors work into that equation, right? So here I've got zone 10 is linked to soil moisture sensor, and that's a primary. That soil moisture sensor is actually set to a lower limit, so it won't water until it dries down to 25.2%. In this case, it still has a time and a date. And then zones 11 through 45 are linked to it. So whatever zone 10 does, all the rest do. So lower limit for soil moisture sensors in drought conditions, absolutely made for this.
Yeah, unless you are mandated that you can only water on Tuesday.
Ooh, so if I've got only water on Tuesday, I better fill up the gas tank or better fill up the soil profile. So that sounds like an upper limit.
As you can,
Yeah.
right?
Mm-hmm.
And depending on what your strategy is, you may just be wanting to fill it up so that you don't, create serious root loss or crop damage or aesthetic value, right?
Mm-hmm.
So you water up to a certain point just to keep that plant material alive without going dormant or dying off. And then that way you can use upper limit threshold water to that.
Yeah. There are, it's a good point to talk about the upper and the lower, because oftentimes, and this is just what I see, lower can be most beneficial when you have rainfall, so that you allow Mother Nature to keep filling up the tank and you prevent irrigation until you reach that lower limit. Where when we look at that drought map, all that red area, there's no rain happening, potentially. Right. No rain happening. And so what we really want to do is, like what Chris just mentioned, if we have certain days to water or certain schedules, we want to just make sure we're applying the right amount could be deficit irrigating to that upper limit. Even if the upper limit's not true field capacity, it could be a percentage below field capacity, because it's not possible, depending on the weather, to water to field capacity all the time.
Yep, for sure.
No, the monsoon rains usually don't make it to us in the summertime, but they definitely are in Arizona, and perhaps where you are, Chris. They're definitely more common there. So summer rains, right? So a lower limit is that opportunity to get that free rain and don't water when it's because the moisture contents come up.
Yep, absolutely. Yeah. So I've done studies on properties here in Utah in the month of August when those monsoonal or thunderstorm conditions exist, and using the effective rainfall from those rain events, you can extend your day cycle by skipping start times that come up, because there's enough moisture in that soil profile and it doesn't require it. So you're letting Mother Nature supplement your irrigation and management strategy, which brings up a brilliant point that Andy made when we were preparing for this is, in the Northeast and even in the Southeast, or the whole, east of the Mississippi, let's just say, there isn't a drought condition that is worrisome. There has been in the past. I remember a few years ago, Atlanta was within, a couple of days of running out of water. Like you'd turn on the tap and nothing would come out. Because their reservoirs had, been depleted and they hadn't had any rainfall. So, but when there isn't a drought condition, Andy, what's your strategy using the new precip sensor technology to manage water efficiently? Yeah,
this is really where we get to combine two technologies, a tipping rain bucket technology and a soil moisture sensing technology, truly into this precip sensor and precipitation management, if you will, so that you can, step number one, pause when it's raining, right? Don't stop when it's raining, but pause, which, visually look the same. Let's just turn the irrigation system off, but we're going to do it temporarily by pausing. And then based on how much it rains and what the soil moisture sensor picks up and reads, if it has reached field capacity, then we'll stop. So it's like this two-step automation: pause, and then see the results, and then either stop, or if not, resume.
Right.
So that's really that two-step: pause, take a look at the data, either resume or then stop based on actual, soil moisture absorption.
That's right. And the key to it too is that you can stop all programs for the whole controller based on that upper limit, or you can just stop individual programs. So if you're, looking at your plane surfaces again, you want to keep them optimal, or the front entry to a property, you want to keep it looking good. You can stop all of the other programs, but allow those high profile areas or high use areas to continue to water without being affected.
Mm-hmm.
So Andy, what's the difference if you just took as soon as it started raining and you just stopped instead of pausing? Why wouldn't you just go straight into a stop condition?
It might only rain just, a fraction of an inch.
Yeah, right.
And then it's done. And then you go right back to high ET again. The sun comes out, it's hot, and it starts to, the moisture starts to go down again. So, it's really that, stop or pause based on rate, and then either resume or not resume based on accumulation or effective rainfall. And the only place you can measure effective rainfall is in the root zone. It doesn't matter what landed in the catchment device. It's how did it affect the root zone?
Yeah.
Best of both worlds then.
Yep.
Beautiful.
Very cool. So we're near out of time, but one thing that I want to address, kind of reverting back to the water budget capabilities. If you do have a mandate that's imposed and what your previous year's water usage was, then you could take that volume of water that you used last year and, multiply it by the percentage that you are mandated to reduce your usage, i.e. take 2.6 million gallons, multiply it by 0.8, and then that's roughly just over 2 million gallons. Then you would input that reduced value into your water budget, and you've got automatic conformance.
Right. That's a good point.
Right. So different ways to use the data and create those conditions from that data. In this case, the data is the flow sensor data. Right. Mm-hmm. So using the data from the technology in intelligent ways to enhance the performance of the irrigation system.
I'm Chris. Last comment, side topic. How many gallons of water does it take to make 1 gallon of beer?
Depends on the brewer, but I think the national average is 19 gallons of water.
To make 1 gallon of beer?
Yeah.
Wow.
I hope I don't have to cut back on drinking beer.
That's another way. I mean, Dan mentioned that we don't consider how much water we're using in terms of dollars, but maybe we should think of it in terms of how much beer we're saving.
Yeah. Well, you'll see in drought conditions, you see bumper stickers that say "Save water, drink beer."
Yeah.
Not the case. Nope. Not for most brewers. So it takes a lot of water to brew beer. Oh, very cool. All right. Well, look at that. We're at the bottom of the hour. We did not have any questions come in today, which surprises me.
They know it all.
Well, we know that's not the case. None of us know it all, but we're here to, educate each other. So if you've got a question, pop it into the chat or the Q&A real quick. Otherwise, we will wrap up for the week. One came in. Jim White, really good stuff. Thanks, guys. We appreciate you too, Mr. White, Dr. Black. So let's take a wrap on it. What do we got up for next year or next week?
Talk about conventional wire. What can you do with conventional wire, but what can't you do with conventional wire? Mainly, I want to talk about, we talk a lot about 2-wire, but we're going to kind of focus on conventional wire. Don't want to exclude anyone in the retrofit world.
I think there's, quite a bit to talk about in that regard. So should be good content for next week. We want to thank everybody for being here. Again, if you want to replay this episode or, rewatch other episodes, you can find us on YouTube at baselinewebtraining.com and all one word. And we are very grateful that you join us week after week, and hopefully we provide good information that you can take to the field to be better water managers. So
right on.
go out, work hard, be safe, save water, and we'll see you next week.
See y'all then.
And drink beer.
Great.
And drink beer too.
Bye-bye.
Bye.